In this video, we'll be taking a look at the basic shading workflow within Maya. We'll start by taking a look at the surface materials available in Maya, and take a look at the Lambert, which is a default shader. When double-clicked, the attribute editor will open and show you all the attributes available for that shader. So you can see the color is easily selectable and changeable by either sliding the slider or clicking on the color to bring open the color picker. Here you can select the color you want by using the color wheel or the HSV, the hue, saturation, and value sliders to dial in the brightness or darkness using value, the amount of color or saturation, or the hue, the actual range of color that you're looking for. Once you like what you see for your color, simply move the mouse off of the color picker and it will commit to that color. Below color is the transparency, which adjusts the see-through ability of that shader. Of course, the less transparency you have, the more opaque or the more solid it feels. The more transparency, the more glass-like that material will appear to be. Ambient color is an attribute that adds a flat color to the dark areas of the shader. The shader is defined by how light hits it and how that light falls off to darkness. By using the ambient color, you can get rid of that darkness and create a more flat look to your material. In my experience, the ambient color is very seldom used, and when it is used, it's done very sparingly with very dark values for the color itself. I typically use the ambient color at black. Incandescence gives the shader a brightness. With some renders, such as global illumination or final gather in mental ray, incandescence will actually light up surrounding objects. However, in typical Maya shading workflow, incandescence will simply give you a flatter look to that object. Again, clicking on the swatch will give you a color. And here we have kind of a cool looking effect when we've added the incandescence to it. Again, incandescence, like ambient color, is used usually sparingly, unless it is for a lighting effect specifically for a rendering algorithm such as Final Gather within Mental Ray. Bump mapping is a way to add a texture, a tactile quality to your shader. Here, you don't get a color, you actually have to use a map. And this is what all these checkered boxes are for next to all of these attributes. This allows you to add a map. We'll come back to that in just one second. The diffuse component of the shader governs how much of the color is diffused across your surface. Typically with about a 0.8 default value, you get a nice fall off on the Lambert shader from the lit portion to the unlit portion of that object. The greater the diffuse, the brighter the object becomes all around, but especially so in the mid-range and going into the unlit range of that. And we'll just leave that at 0.8 for now. Translucence, depth, and focus all have to do with how light comes through that material and is a bit of an advanced feature we'll leave alone for just right now. You can add a glow to any object by giving a glow intensity to its shader. And this is something that you'll see in the render only. So if we create a simple sphere and give it this green shader by right-clicking to bring up the marking menu, you'll see you've got Assign Material to Selection. Let's make sure our ball is selected. Let's go into shaded mode by pressing 5 on the keyboard. And we'll right-click and select Assign Material to Selection. That turns the ball green in the work window. If we render as is, let's go back to the shader, let's turn the glow to 0. If we render by clicking the render button, we'll see the render view, pretty much what we expect. However, if we add a little bit of glow to it and re-render, you'll see it has a glow added to it. Very simple to add. Let's go ahead and turn that off. A few other things in the attribute editor you should take a look at are also ray trace options. This will allow you to refract through the object as if it were a glass. This type of rendering, ray trace rendering, is better used with the Blinn or the Phong shader. Let's take a look at one of those next. Here's a Phong shader. What it does is it adds a reflectivity or a shine that the Lambert is missing, and that is done through these attributes: cosine, spec, reflectivity, and reflected color. The cosine power governs how tight the specular reflection is. Specular reflection is basically the highlight, a glint off of the lighting in your scene. If we go ahead and add a light to the scene real quick, we'll go create lights and we'll create a directional light. And I'll move that up. If I press 7, I'll see how that light works on my object, and I'll do quick lighting like that. Move in on our object, and I will change this Lambert to a Phong. You can see the highlight is created. That's the specular highlight. Controlling that highlight uses the cosine power, something that will spread when it's a low cosine power, or become much tighter, creating a glossier look for that shine by using a higher cosine power. If we render this, you'll see a very nice tight. If we create a much lower cosine power, that will spread quite evenly, making a more dull surface than shiny. Sharing the same specular shading attributes is the Blinn. The Blinn's control over specular shading is a little bit more elaborate, where you get eccentricity, which also governs the tightness. A 0 essentially turns the Blinn into a Lambert shader. The higher the eccentricity, the more roll-off you get on that highlight. That is also controlled by the roll-off. The eccentricity and the roll-off work together to give you a nice range of surface. A low eccentricity with a high specular roll-off gives you a much glossier look than if you had a high eccentricity with a low roll-off, which gives you a bit of a velvet look than it does a shiny plastic look. The reflectivity for both Phong and Blinn, as well as the reflected color, govern how much it reflects. Reflections, true reflections in a scene, happen when you're ray tracing, which is a rendering topic, but it also ties into shading. Talk about one, you talk about the other. Lighting is also very key to shading, so you can't really touch one topic without touching the others as well. In this video, we've taken a look at basic Maya shading parameters, looking at the Lambert, the Phong, and the Blinn shaders, and the attributes that control them.